right, welcome everyone. Today's guest is activating the data science and machine learning community. You might have already heard about Kaggle. Kaggle has over 3 million members to solve real-world problems across industries from pharmaceuticals, technology, energy, financial services, and more. I have the pleasure of interviewing their CEO and founder, Anthony Goldblum. And my first intro was, he was the greatest data scientist ever.
Which unfortunately is not true. I wish it was true.
Well, welcome, Anthony. Maybe you can start telling a little bit about yourself.
Yeah, sure. So maybe you can tell from the accent, I'm originally from Australia. I grew up in Melbourne, Australia. I studied econometrics and statistics at college, and my first job was working for the Australian Treasury, forecasting GDP, inflation, and unemployment. And I loved statistical modeling. That was where my first statistical modeling job. I think part of my job, I sort of used to read industry newsletters and so forth, and I saw there was an academic competition that was run every year called the KDD Cup, and then there was a Netflix prize, and I found these very, very exciting. And eventually, I started working on building a platform to host these kind of competitions in the evenings, and then realized that it was taking me a long time to code up the site, so eventually left my job and started Kaggle we launched our first competition in 2010. And then moved to the Bay Area in 2012 as the community started picking up momentum.
But data science was sort of fairly coming up in that period, right? 2009, 2010. Well, of course, there was statisticians and others, but data science as a field, as a role, would you say it was in the early 2010s?
When Kaggle got started, the term data science had been coined maybe around the same time. It was originally popularized by the former chief scientist at LinkedIn and the former chief scientist or one of the early data scientists at Facebook. And they were sort of frustrated that there wasn't a word to describe. There are all these different disciplines of statistics, machine learning, bioinformatics, and really they were using very similar software, very similar techniques. They came up with this term data scientists. The aim of the term was to become a bit more of an umbrella term. And I would say one of Kaggle's contributions was giving all of these people a single place to hang out and learn from each other. And not only that, also making it clear which sort of techniques worked well. When we started, people were using logistic regression and support vector machines and self-organizing maps. And I think Kaggle's first big contribution was helping people consolidate on random forest. Then really the year that machine learning and AI kind of took off as a concept, I look at it as maybe a subclass of data science, was 2012. We sometimes call that the annus mirabilis of deep learning. That was the year that AlexNet, the very famous neural network that came out of the University of Toronto, smashed the previous best on ImageNet. And that's when neural networks really were introduced. And now today really we see two dominant techniques. We see gradient boosting machines, which is sort of a relatively small evolution from random forests, dominating the smaller structured data problems. And then neural networks have gone on to be particularly successful with computer vision and more recently natural language processing, also with speech. And so those are the sort of two things I think data scientists today are spending most of their time on.
Yeah, that makes sense. I want to go deeper in that, but before that, maybe you could give an overview of your journey at Kaggle. Kaggle is very synonymous with data scientists, which is a pretty amazing thing or amazing brand that you've actually built. And from creating the data science brand to now having over 3 million members, getting acquired by Google, working as an independent company. So it's been a big journey. Would love to talk a little bit about that.
Yeah, I'd say maybe I'd break Kaggle's history up into 3 main phases. There are lots of bumps along the way, but we started out running machine learning competitions, and that's what I described initially. This is where companies will put a problem up on our website and people compete to build the best answer. And between 2010 and 2015, that was pretty much the majority of Kaggle. The thing I'm really proud of is we always realize that machine learning competitions are a nice product, but a relatively small niche. If you think of the total population of the world's data scientists, only a portion at any point in time are going to be interested in machine learning competitions. And so we built a product on top of our competitions that initially was focused on allowing people to share within a competition team and now has broadened out to be a place for data scientists to basically share reproducible notebooks. We call it Kaggle kernels. In 2016, we launched a third main product, which is a public datasets platform. And so this allows our community to share datasets with each other. And so not everybody has time to compete in a competition, and some people aren't interested in any of the competition datasets. So you can almost think of it like YouTube for datasets, where people share data sets with each other, and we have a collection of well over 20,000 public data sets at this point. In 2017, maybe 2018, we added Kaggle Learn, which is ultra short form courses on key data science concepts. And so today, Kaggle is made up of those 4 components: compositions, kernels, data sets, and the educational environment Learn. We were acquired by Google in 2017, but our users, probably mostly invisible, the acquisition to our users. We still operate under our own brand. The one main difference that our users have felt is that as a result of being part of Google, we've been able to offer many more resources for Kaggle kernels users. So we currently offer GPUs. We offer some free GPU quota to our users, and hopefully soon we'll offer some TPUs quota as well.
That's one advantage of being under Google Cloud.
I would say so. There is as a small startup, there's a relatively small amount of compute that we could afford to subsidize. Google has allowed us to be dramatically more generous.
Yeah, absolutely. What would you say you've seen the growth through data science competitions, data science platform, working with companies and others? And obviously, the new domain of anything.ai is so big in Silicon Valley right now. And like AI is so noisy. Everybody claims to do AI, whereas it can just be, I don't know, just like a bunch of if-else code for most part. Can you clarify just from a data science community, hey, what is a data scientist, the role of a data scientist? What is machine learning engineer? What is AI engineer? What is data engineer? When we work with a lot of companies, there is not even clarity across even the nomenclature of what do you refer to who. Is there like a standardized nomenclature, or what's going on right now?
No, I'm not surprised companies are confused, because it is fairly confusing. The definition I like is that a data scientist is an umbrella term. There are different types of data science that somebody can do. One is training machine learning algorithms, and this is sometimes called type 1 data science, where you're building algorithms that ultimately are going into production. This is like, the Facebook news feed or an Amazon's recommendation algorithm or Netflix's recommendation algorithm. These are things that ultimately go into production. Then there's type 2 data science, where the output is actually more of it's not something you put into production, but it's insights that you can productionize. With type 1 data science, you're typically doing more than if-then-else statements. You're training a machine learning model, most often neural network or a gradient boosting machine. With type 2 data science, maybe you're using those tools, but also you can be doing anything as simple as, I think that using pivot tables, for instance, or writing pivot tables is it's a form of data science. Yeah. I classify as a data scientist as someone who writes code in order to produce those inputs. My distinction between a business analyst is somebody who uses Tableau or Excel or something like that, whereas a data scientist is using Python and R, and then as far as what they're doing, they could be doing anything from writing pivot tables all the way through to training machine learning algorithms. Data engineer is the person who hooks up the back-end data systems to allow a data scientist to analyze data. Machine learning engineer is a subclass, in my view, of a data scientist. So somebody who is really specifically doing that type 1 data science, training machine learning algorithms. And then an AI engineer is still a bit of a vague term, but I look at machine learning as a subclass of AI. So within AI, you have supervised machine learning, which is really, I'd say, where the majority of the pragmatic use cases are today. But then there are some exciting areas of AI that I don't know you would call machine learning. So things like reinforcement learning, which was used by DeepMind that was a key component of AlphaGo. And you have other areas, some of the hot areas are like generative adversarial networks, where you're generating images, could be a face or a scene or something. These are completely synthetic. Algorithms are getting very, very good at generating very realistic looking images. And there's been experiments with using it for text, generating text as well.
That's definitely super useful, because it's one thing that when we go and talk to customers, there's always like a confusion of like, are you clear when you say you need a data scientist? Like, what do you really mean? Like, does this person need to write production level code? Does this person actually have to do like internal data analysis? Like, what are you trying to accomplish is super key for our customers to get a better understanding of it.
Completely. And I think it's not unusual relatively early in the market, any market, for there to be some blurriness.
Yeah. Would you say like you have like 80% market share on the data science, like Kaggle community?
The claim I like to make is that the majority of the world's data scientists pass through Kaggle as part of their data science journey. Maybe they do one competition, they do take one of our Learn courses, they come to us to get data sets, they come to us in order to look at a kernel showing how somebody implemented some XGBoost on some kind of use case. So I would be surprised if it wasn't the case that the majority of the world's data scientists hadn't passed through Kaggle. One of our big goals is becoming much stickier to data scientists. So, before you start a project, you come and you look at a Kaggle kernel and you look at how somebody has implemented something that you want to do. When you're working on your project and you want to find a public data set to join to, you come and look at our public data set. So I think we've done a really nice job of influencing the field and helping to figure out what's worked. We are trying to be more useful to data scientists on a daily, weekly, and a monthly basis.
Yeah. Just on the learning and then getting into the data set part, I remember, I don't know if it was either our conversation or one of your tweets or anything, you mentioned like 50% of the job is data cleaning from a data set.
Yeah.
And that's like a big part of the job. And that's probably a lot of grunt work needed before you start to apply all the techniques that you'd like to do. Can you talk to me a little bit about that?
Yeah, we have a joke at Kaggle that 80% of data science is cleaning the data. And
maybe 80%.
Yeah, 80%. And then you know what the other 20% is? It's complaining about cleaning the data.
Yeah.
But, it's funny, the data cleaning is often talked about as grunt work, but I think some of the most important assumptions that a data scientist makes are made in the way you take your raw data set. How do you sample it? How do you fill in missing values? What do you join it with? To the extent you don't have a clean join key, how do you join? And so the one thing I would push back on that you said is that the data cleaning is grunt work. I think it is tedious to do, for sure.
Yeah.
And it is not very glamorous, but I think it is very important.
Yeah.
And how good a job you do of the data cleaning will ultimately determine what you get out of the algorithm that you ultimately train. There's a hackneyed saying that garbage in, garbage out. If you don't feed really nice data into your algorithm, it's not going to find interesting signals.
Yeah, absolutely. And there is, because it's very, very similar, there was a conference that I was going and one of them asked, hey, is AI going to reduce bias in recruiting? And my response was very, very similar. Hey, if you have a biased recruiting process, AI is going to enhance and let you know that, hey, there's just going to be more bias. Like AI inherently does not sort of reduce bias or anything. It's like garbage in and garbage out kind of a thing. But there's this general misconception that AI can reduce bias in recruiting. AI can actually solve all the world's problems and others. At some level, it's making you more efficient from whatever you're already doing.
I think I forget who I heard say this, but whenever you hear someone say, is AI going to increase bias or reduce bias or so forth, I find it often helpful to replace the word AI with stochastic gradient descent. Is stochastic gradient descent going to increase bias or decrease bias? And I think just replacing the word AI with stochastic gradient descent makes it clearer what the answer to that question is.
Yeah, absolutely. And in your process of new people trying to learn data science, where do you think they get stuck the most? I'm guessing it's easier to look at your kernels and run it and get started, but which part of the journey do they actually get stuck?
Yeah, I actually think we have a concept at Kaggle called the wall of engagement. And what we try and do is try and get people over the wall of engagement. Probably the first wall that people hit is a fear of coding.
Oh, really?
Yeah, because a lot of people coming into data science are coming from more of a business analyst type world. And so they're used to Excel. And it's funny because you could think of Excel as almost like functional programming, which is a relatively advanced form of programming. And so to the extent that you're using Excel effectively and you're doing things like pivot tables, I think you are doing more complicated things than coding. One thing we have tried is we have a very, very simple, we call it maybe an entry point, or sometimes internally we joke that it's a gateway drug into Kaggle. We have a very simple competition where you're trying to predict who survived the Titanic based on gender, class of ticket, etc. And so we try and make it very simple, where the first thing you do is we have an Excel tutorial. So if you just simply in Excel take if female then survived, if male then didn't survive, you'll get about 80%. And so you do that in Excel, then implement that in Python. It's really not that, so you know what it looked like to implement it in Excel, then you have the experience of implementing it in Python. And that's the kind of thing that we try to get people over that initial wall of engagement, being the fear of programming.
I see. I would have expected more, the level of ambiguity might actually pull back a lot of people in data science problems.
What do you mean by that?
There is no straightforward answer to it. Unlike, for example, if you were learning how to code, like there are a bunch of other learning how to code sites where it's sort of like mostly binary to a large degree of whether you got this problem. Like, if you come to HackerRank and you continue to progress and others, I thought the level of ambiguity and like where it is might have actually distracted. That's interesting.
It's actually interesting that you say that, because I think your comment is very accurate for software engineers. So software engineers who move into data science, machine learning, they obviously do not struggle with the ability to code, right? Yeah. That's not the thing that holds them back. But sometimes the thing that software engineers find frustrating is, let's say your model is performing strangely. If you have code that is performing strangely, you can deterministically trace back and find the source of the bug. To your point, it's never nearly as clear with machine learning. Like, is my model overfitting? Is the data I fed in incorrect? Or have some anomalies in the data? Is my model converging to some weird local optimum? All you can do is experiment, but you can never sort of deterministically.
There's no debugger.
Yeah, exactly. That is definitely something that software engineers find frustrating as they try and pick up machine learning. The lack of comfort with the ability to debug very specifically what's going wrong is definitely something that holds software engineers back.
Yeah. And then on the other side, I've also heard, and I would love to take your opinion on this, is it's not just enough if you are able to build a model or even like productionize it. You should have like really strong business understanding and communication skills in order for you to be a strong data scientist. So just because you're a great developer and you can understand R, Python, and productionize models, it's not enough. Talk to me a little bit about how important that is and why.
Yeah, for sure. This is actually an interesting one with respect to our competition. So we put a competition up, and whatever the structure of the problem, people will build an amazing algorithm on that problem. But if the evaluation metric is wrong, the target variable is not the variable that is useful to predict, then the algorithm is completely useless, right? Yeah. And so the process of effectively building an effective algorithm requires you to be strong technically, but it also requires you to have good business context. Frankly, I find it one of the more interesting aspects of the profession. And it's probably true for software engineers as well. In order to build a great piece of software, you have to understand how it's going to get used. And so the best software products are, understand the business context in which the software is going to be used. I don't think it's so dramatically different for machine learning.
Yeah. How do you think about assessing in your competitions or even in your general recruiting process?
I would say the competitions we run, one of the limitations is they only lightly test domain expertise because the problem has been set up for you. And so I would say there's a bit of a meme that comes up from time to time. Doing well in Kaggle is not equivalent to being a great data scientist.
I'm pretty sure that's a Hacker News comment.
Probably, yeah. I would say there were somewhere between 200 and 300 Hacker News comments that have said something along those lines. I believe that comment is partially true, but not completely true. But to the extent that it is true, the major thing that Kaggle does not train you to do is take an ambiguous problem and turn it into a concrete machine learning use case. That being said, one thing that is very powerful about Kaggle is there's no other way to work on such a variety of problems in a relatively short period of time. And so Kaggle ends up being kind of interesting because you see what well set up problems look like. And so when you are faced with an ambiguous problem, in a work environment or whatever, you sort of have some targets. You have a sense for, okay, I've seen a competition that sort of was structured like that, and if I can get this sort of ambiguous problem into that format, I think Kaggle is less useless for problem setup than is often said.
But there is a level of ambiguity because you use public data sets and none of them are usually perfect and they have all their own flaws and others, right?
Yeah, I mean, we actually often don't use public data sets. We use data sets that companies allow us to make public.
Even better, it's not going to be perfect.
Yeah. Even for a Kaggle competition, what they're saying, I said before about 80% of data science being cleaning data and 20% being complaining about it. It's still roughly true. It's not that hard to training a light GBM model or a Keras model. Light GBM is really nice API, maybe 2 lines of code. Keras, beautiful API, maybe 3 lines of code. The difference between, those who win Kaggle competitions are not winning them off the back of tuning hyperparameters for XGBoost or Keras better. They're doing very logical things. They're handling the data well. I'll give you a nice example, actually. We ran a competition. This is a defense-related use case, and they wanted to take satellite images and order the satellite images chronologically. Seems like an unusual use case, but they had reasons for wanting to do it. And people were very, very clever. they would do object detection to find construction sites, because a construction site only moves in one direction. That was one thing that, so that's a very clever insight, but it's not a technical insight, right? Another thing people did was they looked at the shadows to get the time of day. How the shadow is cast tells you a lot about the time of day. They'd identify churches in pictures, and if it was, they'd look at a church parking lot, because if it was Sunday, it was more likely to be a church. These are the kinds of insights that won that competition. And that's also a thing I absolutely love about machine learning, is very often, yes, as a base level, you've got to be able to operate these algorithms, but very often you get a chance to show, really clever, the insights you find are really cool and interesting and fun.
What do you see as are like some of the common mistakes that people make when hiring data scientists or machine learning talent? Maybe more specifically, type 1 data scientists, like how you described.
The thing we always found most useful when we were hiring data scientists was to give them a project that we cared about, or that would look like a project that they would tackle internally, and how they did on that project. We'd give a 4-hour window how they did on that project. We learned more from that than anything else, frankly. It's not just where they got to. Yes, how far they get on the project is interesting, but how they explain their decisions is very useful. And particularly when we used to give the same project, to everybody we interviewed, and you get a good sense for what's a good performance on that project.
And then you bring the person on site to
do a code review.
Do a code review.
We'll present the project. Yeah, we would do it we're a distributed team, so we'd often do it via video conference. And I think there's just about no substitute for that, because a good data scientist can come from a very wide variety of backgrounds. Could be machine learning, could be bioinformatics. There are these programs that take PhD physicists and turn them into data scientists, and because the field is so new, the variety of backgrounds are pretty varied. I mean, frankly, we have a bit of a hiring advantage. We hire out of our community, and our community is actually a very good signal. People who do well on Kaggle competitions, similarly, you cannot fake that. It takes some skill to learn to read a Kaggle profile. If you're looking at a Kaggle profile, I actually care as much about competition performance is interesting, but when we hire for our team, we grade people on 3 criteria: their competition performance, the kernels they share, how many upvotes they get, or the notebooks they share, how many upvotes they get, and their contribution to discussion, as in when they talk in the forums, how many upvotes do they get. Of the 3 criteria, typically I will interview anyone who's done well in any of those 3 criteria. Of the 3 criteria I care about most, it's a little bit counterintuitive, I care most about discussion. The reason being is we have a very, very smart community, and you only get upvotes if you are technically insightful and you're a clear communicator.
Yeah.
So competitions, you can be technically insightful or technically strong, but not a clear communicator. For a nice notebook that gets a lot of upvotes, it has to be technically strong, and it shows some degree of communication, like was it well commented and well documented. But discussion, you must be both very strong technically and it's a very good signal, and is somebody a clear communicator. For some people on Kaggle, they think of the competition ranking as like the more pure ranking, and that is not I have a different perspective.
Yeah. Like we discussed earlier, the rubric of a data scientist just doesn't end with, are you able to write good code?
Yeah.
But are you able to communicate well? Do you understand the business context? Carries a far higher weight compared to any other sort of engineering role.
Completely. Yeah. I think it is important in other engineering roles, but you might be right that it's even more important in a...
Right. I mean, like other engineering roles, yes. I mean, if you grow up the ladder of, you become a director of engineering or a VP of engineering, for sure, yes, the amount of communication and other business context plays a far bigger role. But I wouldn't say for an individual engineer, yes, you do need to communicate well, but the weightage that you give to that is way higher for a data scientist
I would agree.
than an engineer. Yeah. And one of the more interesting things, and you're probably familiar with Insight Data Science, it's a YC company. Jake is doing a fantastic job in that. And Insight presented this cool report of how PhDs from such a diverse set of backgrounds, from physics, astronomy, and English and all of those things, have gone on to become strong data scientists in tech companies. I mean, the level of diversity in terms of background is so high in data science compared to any other engineering field.
Yeah.
When we start to observe. Can you talk to me a little bit about that? Have you observed the same, and why do you think it's...
Completely. There was I think his title was president of the Royal Statistical Society in the UK, had this fabulous quote where he said it's a real triumph of statistics and data science more generally, that being considered literate in your field requires you to have an advanced knowledge of statistics and data science, right? So you can't really be a physicist without being good with data science. You can't really be an electrical engineer without having a lot of the skills. And certainly this was something we found very early in Kaggle's life. And I haven't tracked the extent to which it's still true, but of all the academic backgrounds that did best on Kaggle competitions, we actually found very early on it was physicists and electrical engineers.
Why do you think that's the case?
So my hypothesis is that they have to have the raw technical skills, the programming and the statistical skills, but they're using it for the purpose of solving a problem. So they're pragmatic problem solvers as well as having the raw skills. So if you're a theoretical machine learner, maybe you're good at writing proofs. It doesn't necessarily make you good at connecting that algorithm to use it effectively on a real use case. And so that was my hypothesis around why physicists and electrical engineers did particularly well. To be honest, that's a fairly old finding at this point. And so it'd be an interesting one to refresh.
It'd be fun to see the different levels that you have, like Kaggle Grandmaster. What's like the major backgrounds?
Russian. No, I'm joking. 2% of our community is from, let's say, Russia, but about 10% of grandmasters. So, and I think that really what's going on there is there's a lot of emphasis on math and science. That we actually have the US, Russia, the UK, Canada is very strong in terms of representation from grandmasters. We only have 110 grandmasters. It's a fairly small and really elite pool, and it's decently geographically diverse. The number one at the moment has been number one for a long time, and he is very, very hard to beat. He's from China. Number 2 is from Brazil. Number 3 is from Russia. Number 4 is from the UK. So it's a nice spread.
Yeah. No, absolutely. What's next? What do you think is going to happen more from like Kaggle's perspective as well as the general data science, AI? What do you think are going to be the big shifts that are going to happen?
Yeah, I mean, Kaggle's biggest priority internally is something I said earlier. We want to become much more useful to data scientists on a daily basis. So to give you an example, we now have several 100,000 notebooks on anything you could imagine wanting to do from a machine learning perspective. So let's say you want to train a light GBM model. I don't believe you should have to start from a blinking cursor, but you should be able to come to Kaggle, see how somebody else has implemented a light GBM on a use case that looks like yours, and use that as a model for your own work. Already, if you Google a lot of machine learning concepts, we end up being the number one search result. So whereas 5 years ago it might have all gone to Stack Overflow, a lot of the error messages still go to Stack Overflow. A lot of the how-to queries end up on Kaggle.
Well, now you're closer to Google.
Yeah, right. Yeah, we should. Yeah, that's a good idea, actually. Second huge opportunity that we see is we want our datasets platform to be the one place that you go to find datasets. Yeah. Today we have 20,000 datasets, but you think about the problem of finding datasets. You do a Google search, you trawl through 30 results. It's really not a very fun process. And we are looking, our datasets platform has these nice features. People share their analysis on top of it, where it's currently exploring this idea of allowing people to fork datasets. So you don't just have to take the Census Bureau, the raw census data, but you can take forked versions that are more nicely presented. So we want our datasets platform to be the one place you go to find datasets. Those are some of the things internally we're working on. As for the field more generally, I guess I have kind of two answers to that. One is, there's the somewhat hackneyed William Gibson quote that the future is already here. It's just not widely distributed. Companies like Google, Facebook, Amazon use machine learning very effectively. I think the next major trend is either getting sort of existing large companies that have lots of data starting to get a good intuition and good processes for leveraging machine learning, or, ultimately getting disrupted by startups or others who figure out how to use machine learning in a better way. The other kind of area that's getting a lot of attention at the moment is, I mentioned to you earlier that 2012 was the miracle year for computer vision, and we're starting to see, autonomous cars and radiology and security cameras and so forth really benefiting from the advances in computer vision. You could argue that 2018, where the early signs are that it was the annus mirabilis for natural language processing. There was a big breakthrough from a Google team algorithm called BERT, and now it's a transformer-based natural language processing model based on another flavor of neural networks. And there have been a lot of innovations on top of that subsequently. And so there is a decent chance that the next big area of breakthrough ends up being around natural language processing. And, just as autonomous cars and radiology and And some of the security areas have been use cases that are currently being unlocked by computer vision. What sort of use cases might we see around natural language processing over the next 5-10 years?
Yeah, Gmail is already starting to do that.
Yeah, it's fabulous, isn't it? I love it.
That's awesome. Thank you, Anthony, for your time, and continue to grow the data science community.
Well, thank you.
Thank you for tuning in. If you have any questions, tweet us at HackerRank.